In recent months, a stunning discovery has shocked scientists and every observatory gazing into deep space. Bill Nye, the famed science educator, revealed Voyager 1 had found over 300 massive objects floating in the cosmos. This surprising revelation has stirred curiosity in observatories and among those tracking signals from the universe. Questions began to form in every lab. What are these objects? Where did they come from? And what secrets does the galaxy hold? For nearly 5 decades, the Voyager missions have reshaped our knowledge of the solar system. Originally, these 2 tiny spacecraft were never expected to survive beyond Jupiter or Saturn. In the 1970s, Michael Minovich introduced the concept of using gravity assists for space travel. This simple idea of slingshotting spacecraft using a planet's motion pushed Voyager deeper into the stars. It was meant to be a 5-year mission, but it became one of the longest-running projects in astronomy. Launched weeks apart in 1977, Voyager 1 and Voyager 2 began exploring the outer planets. They started with Jupiter, capturing mesmerizing images of swirling storms and volcanic moons. Soon after they turned towards Saturn, where they sent back first-ever views of its ring system. But Voyager didn't stop at the planets. It continued into interstellar space. Voyager 2 did what no probe had done before, observing Uranus in 1986 and Neptune in 1989 from orbit. It was an endeavor so bold it earned the title the Voyager Grand Tour in space exploration history. Beyond the Sun's magnetic shield, both probes pushed deeper into the void. Now, more than 45 years later, both Voyagers are still transmitting data from deep spacecraft distance. In 2013, NASA declared Voyager 1 officially entered interstellar space, a realm beyond solar wind. It was as if the spacecraft stepped out of a noisy cosmic city into a silent starlit wilderness. Voyager 2 joined in 2018, over 17.7 billion kilometers away from the shining sun. These old machines remain the only human-made objects cruising through untouched regions. They help us understand the heliosphere, a vast bubble of particles blown by the sun's energy. At its boundary, the heliopause, where solar wind meets interstellar matter, acts as the solar system's last protective barrier. Crossing this area is like exiting the solar system's final shield into open space. Voyager's data has provided rare insights into this transition zone surrounding our star. One surprising discovery: cosmic rays are significantly stronger beyond the heliopause edge. It's as though the probes stepped out from behind a shield and faced the universe's full intensity. In 2023, Voyager 1 detected a persistent humming noise caused by interstellar gas vibrations. Nicola Fox of NASA's Heliophysics Division said Voyager transformed our knowledge of the sun's reach. Even now, both Voyagers operate on fading plutonium power, slowly losing strength in the cold void. To conserve energy, NASA turned off non-essential systems like onboard heaters for the equipment. Still, since 2019, all 5 science instruments have stayed functional in deep cold. This baffled scientists. How can such devices operate in extreme space frost? Their durability defies expectations, becoming a mystery in deep engineering. The heliopause, too, proved more unstable than believed, twisting in unpredictable patterns. It doesn't form a stable bubble, but shifts and warps across the galactic frontier. Voyager 1, Voyager 2, and IBEX, NASA's interstellar boundary explorer, studied this evolving shell. In 2014, IBEX saw a sudden brightening of energetic particles, hinting at disturbance. These data didn't fit existing models, adding complexity to our cosmic boundary understanding. The most puzzling fact: Voyager 1 and Voyager 2 crossed into interstellar space 6 years apart. Their paths were similar, yet the timing differences suggested unknown forces beyond the solar shield. This gap challenges how we view the sun's role in shaping nearby galactic regions. In a Nature astronomy paper, scientists labeled these mismatches anomaly signals. They might force a revision of our solar system's outer structure. To investigate further, NASA will launch IMAP, the Interstellar Mapping and Acceleration Probe, in 2025. Its mission will focus on the heliosphere's mysteries using advanced scanning technology. While we wait, the Voyagers continue their trek into the endless black canvas of space. In May 2023, Voyager 1 faced a technical malfunction involving its attitude control system. This crucial system keeps the high-gain antenna aimed at Earth across the sky. Suddenly, the craft started sending incoherent signals as if struck by a digital fog. The transmissions became random, almost as if Voyager developed a kind of space aphasia. Despite the garbled data, Voyager's signal strength remained solid from the distant stars. Oddly, the spacecraft's safety systems weren't activated, and all instruments worked as normal. NASA traced the issue to a decades-old computer system somehow reactivated by an unknown command. Switching to a different system fixed the problem, though its true cause remains a deep puzzle. Could a rogue cosmic particle have triggered the glitch, or something even stranger? The spacecraft's computer only has 70 kilobytes of memory, less than a modern watch. Still, it continues transmitting data from nearly 23 light-hours away in the cosmos. As they journey farther, both Voyagers face unprecedented challenges with every new starfield. They encounter extreme radiation, strange magnetic fields, and ancient software eroding in the void. These were conditions no one had ever prepared for, challenges once thought unimaginable in spaceflight. Yet, they persist, enduring against all odds, showing us the durability of human craftsmanship. Voyager 1 and 2 are car-sized spacecraft, ancient relics from an analog era. Their cameras and processors seem primitive compared to modern satellites, but they delivered wonders. Stormy Jupiter, Saturn's ring system, Neptune's blue atmosphere. Jupiter was once thought calm. Voyager showed us wild hurricanes the size of entire continents. Its camera captured auroras, thin rings, and volcanic activity on its moon Io. Saturn, too, stunned scientists. Its rings contain thousands of thin, braided ringlets. Uranus and Neptune, once blurry points, became vivid blue giants with dynamic weather systems. But perhaps most thrilling was the surprise from the moons Io, Triton, Europa, and Enceladus. Triton displayed nitrogen geysers erupting into the freezing void at near absolute zero. Io revealed erupting volcanoes, painting a fiery landscape far from the sunlight. And beneath icy crusts, Voyager hinted that Europa and Enceladus may hide subsurface oceans. These oceans make them top contenders in the search for alien life within our galaxy. The most poetic moment came in 1990 when Voyager 1 turned back toward Earth. Carl Sagan requested it take one final image, a tiny pale blue dot suspended in a sunbeam. From 3.7 billion miles away, Earth looked like a speck in a shaft of cosmic light. That image humbled humanity, reminding us of our smallness amid the grand universe. Since then, both spacecraft have entered the interstellar medium, unseen by human eyes. Each day, they drift 3 to 4 light-seconds farther from the planet that created them. Their signals, though faint, still reach NASA's deep space network of radio telescopes. As Earth fills with more noise, hearing Voyager's whisper becomes a true challenge. Yet those whispers continue delivering knowledge from across the vast expanse. Voyager's origins began with rare planetary alignments in the 1970s and 1980s. NASA seized this once-in-a-lifetime opportunity to explore 4 gas giants in one go. Despite budget cuts and primitive technology, the mission took shape, defying bureaucratic gravity. Voyager 1 and 2 have now become humanity's farthest travelers through the cosmos. They are our ambassadors to the stars, messengers of human curiosity and hope. Their mission isn't just about distance. It's about opening the frontiers of the unknown. Each byte of data carries insights that change how we see the universe and our place in it. In their silence and their signals, they ask the same question we do. What else is out there in the void? And now these 300 objects Voyager 1 detected may be the first hint of something unthinkable. Were they ancient ships, uncharted asteroids, or manifestations of a new phenomenon? We don't yet know, but the sky remains full of possibilities, pulsing with cosmic mystery. As we search deeper, Voyager leads the way, not just a machine, but a symbol of our quest. A journey powered by science, shaped by discovery, and fueled by endless wonder. Their mission isn't finished. It continues to unfold beyond the edges of comprehension. And so the Voyagers travel on, unseen, unsung, and always reaching for the infinite. Subscribe to our channel and thanks for watching.